Hello there, my name is Ifan, and in this video I'm going to show you how to create your own dimension in my local movement system for VRChat. So I'm currently in the demo scene, which you can find in this folder right here. So to start with, I like to start with an empty game object, since this gives me great control over the rotation and position of any objects within it. Also the scale needs to be 1:1:1, otherwise stuff is going to break. So I'm going to move this towards me and create a cube to make a platform. There you go. And this cube should only have a height of 0.2. Okay, to add a controller, you can go into the main folder, and in implementation expansion, there is a dimension controller, and we can drag this directly to our game object and convert it to a Udon behavior. Also, we want the player transition to be detected, so I'm going to add this transition detector to this game object. This has a disabled mesh render, since it usually shouldn't be seen in game. So I'm going to move it up a bit. Also in VRChat, the player has a collider with a diameter of 0.4 meters. So we want to subtract 0.2 meters from each side, or 0.4 meters in total. So I'm going to subtract 0.4 from the X and Z scale. There we go. And we can now disable the mesh render again. We also want to link our dimension to our transition detector. So I'm going to move this game object here with the controller into the enter dimension. There we go. And I'm also going to rename this to test dimension. Next up, there are two ways of adding this dimension to our world, either directly or as a prefab, which makes future implementations easier. So I'm going to copy this so I can show you both ways. So first of all, to implement it directly, I'm going to add it to the world dimension, since, for example, this is where it should live in. And so first of all, I'm going to link my world dimension in this test controller so that it's linked correctly. And also the exit dimension, whenever the player exits the trigger, should also be the world dimension. And finally, in the dimension holder, we want to add this one to the dimensions. There we go. So this process can also be quite tedious for larger projects. So in addition, there's also the option to create a prefab directly. So in additionals, there is a prefab organizer script. So I'm going to create a new empty game object, actually in this one. So it's in the correct position, and I'm going to reorder the hierarchy. There we go. And I'm going to call this prefab test. And I'm also going to add it to my folder here, so we can actually work with the prefab. So I'm going to add the prefab organizer script to this and convert it to Udon behavior. And here in stuff to be assigned by the creator, you will find all the things you need to assign. So in our case, that's just the dimension controller and the transition detector. And when we go back, we can now put this back into the world dimension. And first of all, we only actually need to assign the parent dimension, and we need to add it to the dimension holder in prefab organizers. And this will set everything up, so it will set the correct exit dimension and so on once we hit play. So in order to control the position and rotation of this dimension, we want to create a new script. So I'm once again going to go into my folder and create a new Udon Sharp script, and I'm just going to call it test dimension mover. There we go. We can ignore this warning once the compiling ends. And we can open the script up. And this is where you can write your own script. So instead of writing a new script, I'm going to show you based on this platform and this boat on how you can write your own. So we first of all want to control the position and rotation. And we also want to make sure that all the players have the same information. So there are two different ways of doing this based on what type of dimension you want to implement. This boat, for example, is controlled by players, so we want to sync the information from the owner to the other players. However, for this platform, this just moves forward and backwards, just purely based on time. And we can actually just use a synced time, which we can get from the server, and we don't actually need to sync any data, we can just base it on that. So I'm going to start with the platform. So by clicking on it, I can open the prefab, and we can see that it's implemented as I mentioned before. So there's a controller which controls everything. This platform basically just moves between this controller and this target. So I'm going to open up the script. So the main thing we change in this script is actually the local dimension position of the linked platform, which is just the local position relative to the linked dimension. And there's also a rotation value. So when going back to Unity, this is actually the same as, for example, in this test dimension that we created before, the position and rotation values relative to this world up here. So the platform is moved by using a lerp function between the start and target position, and these obviously need to be in local coordinates relative to the parent dimension. So we get these positions by, first of all, getting the linked parent dimension of our platform, and then by using the inverse transform point, which converts a absolute coordinate into the local coordinate of the transform. So there are different ways of using time in Unity. For example, the time.time is commonly used. However, this is the local time relative to when you started up Unity and is not synced. In order to get a sync time, you want to get the server time. Also, you want to make sure that this is a double, since if it's a float, the value will likely be so large that you get errors. In order to get the float that you actually need, you can use the modular operator. Just make sure that you have a positive value in the end, since the server time can for some reason sometimes be negative. And the rest is just a simple function to calculate the lerp value. You can also use a animation curve, for example. So to complete this tutorial, we're going to look at the boat to see an example of a controllable dimension. So I'm going to open up this prefab. So the position of this boat is controlled by a boat controller, which also just moves the local position and rotation values as in the other script. Also, we want to sync the position and rotation values with this boat. So in order to make stuff simpler, I've created these sync scripts, which you can directly add, and they will sync the values from the owner and directly applied to the other players. In-game, this boat is controlled with the wheel and the throttle, which the players can grab and move around. And these just output a value between -1 and 1. And they also set the ownership of the boat to whoever grabs it. Also, because this local movement system doesn't really support rigid bodies very well at the moment, I've added these colliders at the front and back in order to detect the collision so I can stop the boat. So we're going to take a look at the controller right here. So as mentioned in this implementation, I can get the wheel and throttle values directly from these controllers. So whenever the boat should be moving and is not colliding, I can simply add a offset to the current position. Also to mention is that you can use this local dimension rotation in order to, for example, calculate the forward direction. So I hope this video is helpful and allows you to create new and awesome designs.